In this video, we're going to talk about profit maximization for a perfectly competitive firm, and also the derivation of the short-run supply curve for a firm in a perfectly competitive market. In an earlier video, we used marginal analysis to determine at what level of output a firm would maximize profits or minimize losses. Any profit maximizing firm that stays in business will always produce at the point where marginal revenue equals marginal cost. That's illustrated in this diagram. In this case, if the price of output is P0, marginal revenue equals that price because it's a perfectly competitive firm, and marginal revenue equals marginal cost to the point where the marginal revenue and marginal cost curves cross at an output level of Q star. And we can note in this case that because the price is above the average total cost curve at that point, the firm is going to be making some positive profits because it's receiving more in revenue from each unit, the price, than it costs to produce each unit. But we're going to look at that in a bit more detail now. The total revenue of a firm is simply defined to be price times quantity. In this diagram, we can see that at a price of P0 and a quantity of Q star, total revenue is just P0 times Q star, which is just the area of the shaded blue rectangle on the diagram on the right. In a similar manner, we can compute total cost. And we can write total cost as total cost divided by quantity times quantity. Or in other words, total cost is equal to average total cost times quantity. So if we look at the cost per unit, we multiply that by the number of units, that gives us total cost. At an output level of Q star, the average total cost curve tells us what the total cost of producing Q star units of output is. And if we look at the shaded rectangle here, the height of that rectangle is average total cost, the base is quantity, so the area of that rectangle is just average total cost times quantity. Now we have total revenue and total cost. Looking back, total revenue is this blue rectangle, total cost is this reddish rectangle, so profit is just total revenue minus total cost, which is that larger rectangle minus a smaller one, and that's just equal to this yellow rectangle in the diagram that now appears on the screen. So that's one way of measuring profit using this diagram. We find total revenue, we find total cost, we subtract total cost from total revenue, and that leaves us with profit. Alternatively, we could write profit as profit per unit times the number of units of output. Profit per unit is just equal to profit, which is total revenue minus total cost divided by quantity, and we multiply that by quantity. It seems like a roundabout way of getting to this, but we'll see why this is valuable in just a second. If we distribute out the term on the left, that becomes total revenue over Q minus total cost over Q, and we multiply that profit per unit terms by quantity to get profit. But the first term, we know total revenue is equal to price times quantity. When we divide that by quantity, that's just equal to the price. The second term in parentheses is total cost over quantity, which is just average total cost. So profit per unit is just equal to the price per unit, which is also called average revenue, minus the cost per unit, which is average total cost. The difference between the price per unit or the revenue per unit and the cost per unit is just the profit per unit. And if we multiply that by the number of units, we get total profit. Now, if we look at this diagram, that shaded rectangle, which we already determined was profit, has a height equal to price minus average total cost, which is just profit per unit. The base of that is the number of units. So this is another way of illustrating or explaining why that rectangle is the level of economic profits. Now, not all firms, though, receive positive profit. In fact, many firms lose money. So one of the questions we have to ask is, what happens if a firm is losing money? In general, we know that if the price is above average total cost, it's making profits, but if the price is below average total cost, it's going to experience a loss. The question, though, is, if the firm is losing money in the short run, should it shut down? And the answer to that involves a comparison of the losses that it receives by staying in business with the loss it would receive if it shuts down. And we know that if the firm shuts down, it wouldn't have any variable costs, but it would still have its fixed costs. So if you shut down and you don't produce anything, You still have to pay your mortgage. You still have to pay interest payments on loans. You may still have to pay some utility bills. You may have to pay for rent on your building. So what we need to do is determine if the firm were to continue operation, whether it would lose less money than if it shuts down. And the firm would choose to stay in business if the loss it receives is smaller than if it shuts down. And that would occur if the revenue it receives by producing output is more than its variable costs. Because if the revenue is enough to cover all of its variable costs and then something towards its fixed costs, it's going to be better off than not receiving any revenue to cover some of those fixed costs. But if the total revenue is less than variable costs, dividing both sides of that by Q, we know that total revenue over quantity is just the price. Variable cost over quantity is just average variable cost. So in other words, the shutdown point for the firm is that it will shut down in the short run if the price falls below average variable cost. Now, let's look at this a little bit more carefully. If the firm stays in business and the price is below average total cost, we know it's losing money. In this example, when the price is P1, that's above average variable cost. So now if we look at that shaded rectangle, the height of that rectangle is now equal to the loss per unit because it's the difference between the price received and the cost per unit of output. So the height of that is loss per unit. We multiply that by the number of units, and that gives us the total economic losses. So the firm would lose money if it continues to produce in the short run. But if it shuts down, it would lose all of its fixed costs. And we know that in the diagram on the right now, the height of that rectangle is equal to average fixed cost. We multiply that by the number of units, and that gives us total fixed cost. So if the firm shuts down, it would lose that big rectangle on the right. If it continues to operate, it would lose that smaller rectangle in the diagram on the left. So in this case, the firm would choose to stay in business. And as long as the price is above average variable cost, the firm's making enough to pay for its workers, its raw materials, and the other variable costs needed to continue to produce output, even if it's not covering all of its fixed costs, because the alternative is shutting down and not being able to pay anything towards its fixed costs. One other point we can talk about is this break-even point. Break-even point is the price at which price equals average total cost. Because price equals average total cost, revenue per unit equals cost per unit, and economic profit equals 0. We'll talk about what that means in more detail in the next video. For now, we can just note that the firm at this point would just be covering all of its opportunity costs, and the owners wouldn't be better off doing anything else. We can also look at what happens at alternative prices. If the price is P0, point where price equals marginal cost, is below the average variable cost curve, so the firm would choose to produce nothing. If the price is just equal to P1, the firm would be indifferent between producing Q1 units of output or shutting down. But for any price above P1, the price would be strictly above average variable cost, and the firm would be better off continuing to produce. So when the output level is just equal to P1, it would just be barely willing to produce Q1. For any price above that, it would move along that marginal cost curve. For example, at a price of P2, which is that break-even price, the firm would produce Q2 units of output. If the price goes up to P3, it would produce Q3. If the price is P4, it would produce Q4. What we can note by this, though, is that if we take any price and we go over to the marginal cost curve, as long as the price is above the minimum point on the average variable cost curve, the firm would always choose to produce the quantity of output specified by the marginal cost curve. And what that tells us is that the portion of the marginal cost curve that lies above average variable cost is the short-run supply curve for a firm in a perfectly competitive market.